Norway's spectacular fjords are among the most beautiful landscapes on Earth, but these breathtaking waterways also create one of the country's greatest transportation challenges. Every day, thousands of commuters depend on ferries to cross these deep fjords, often waiting long periods before continuing their journey. The E39 Coastal Highway stretches for more than 1,000 kilometers, interrupted repeatedly by wide, deep fjords carved by ancient glaciers. To solve this problem, Norwegian engineers began exploring solutions that had never before been attempted on such a massive scale. Instead of building above the water or beneath the seabed, engineers proposed something entirely different: a tunnel suspended beneath the ocean itself. The tunnel would remain safely below waves and ship traffic, while floating high above the uneven seabed hundreds of meters below. Before construction could begin, every concept had to withstand years of rigorous testing against waves, currents, and changing weather conditions. Specialized laboratories recreated some of the harshest marine conditions imaginable to ensure the structure could remain stable for decades. Every meter of the fjord floor must be carefully mapped, revealing underwater terrain that will influence every aspect of the tunnel's design. With years of planning complete and engineering challenges understood, Norway prepares to begin constructing what could become the world's first floating tunnel beneath the ocean. Every element of the floating tunnel begins as a digital model, allowing engineers to study every connection before construction ever starts. Inside the tunnel, multiple safety systems operate together, providing emergency escape routes, ventilation, monitoring equipment, and maintenance access. Powerful computer simulations calculate how millions of tons of pressure will travel through every section of the floating structure. Unlike conventional bridges, the tunnel relies on giant floating pontoons that quietly support its immense weight from the surface. Every floating support is strengthened with thousands of tons of reinforced steel, designed to withstand decades of harsh marine conditions. Once completed, each floating support must be transported with extraordinary precision before permanent installation begins. Where additional stability is required, gigantic gravity anchors secure critical sections of the tunnel deep beneath the fjord. These powerful steel cables balance movement and stability, allowing the tunnel to flex naturally without compromising structural integrity. Before a single section enters the water, engineers test thousands of virtual scenarios to eliminate risk and improve long-term reliability. With the design complete and every system verified, construction enters its most demanding phase as the first tunnel sections begin their journey toward the open fjord. Construction begins inside one of Norway's largest marine fabrication facilities, where each tunnel section is built under carefully controlled conditions. Thousands of precisely positioned steel bars create the internal skeleton that will strengthen each concrete tunnel segment for decades. Every millimeter is digitally inspected before concrete is poured, ensuring each section meets exceptionally tight engineering tolerances. Specially engineered marine concrete flows continuously into massive molds, forming walls capable of resisting extreme underwater pressure. Careful vibration removes microscopic air pockets, creating an exceptionally dense concrete structure designed for long-term durability. The concrete cures slowly under carefully controlled conditions, allowing maximum strength to develop before the segment leaves the fabrication yard. Once curing is complete, the giant molds are removed, revealing one of the largest prefabricated tunnel sections ever constructed. Advanced non-destructive testing confirms that every tunnel segment meets strict structural standards before transportation begins. Dozens of computer-controlled transport modules work together as a single machine, moving thousands of tons with remarkable precision. With fabrication complete, the enormous tunnel segment begins its carefully orchestrated voyage toward the offshore construction site, where assembly will continue on the open water. Transporting each tunnel section requires extraordinary coordination, as every movement must remain perfectly controlled throughout the journey across the fjord. The transport vessel carefully submerges itself, allowing the massive tunnel section to transition from the deck into the surrounding water. Dynamic positioning technology automatically compensates for wind, waves, and currents, keeping the floating structure precisely on course. Multiple synchronized cranes distribute the enormous load evenly, preventing stress concentrations during one of the project's most delicate operations. Before joining begins, engineers verify alignment to within just a few millimeters, ensuring the entire tunnel remains perfectly straight. Hydraulic positioning systems move each section with extraordinary precision, allowing the enormous structures to connect almost seamlessly. Specially engineered waterproof seals create a permanent barrier, protecting the tunnel against constant hydrostatic pressure from the surrounding fjord. Immediately after installation, underwater inspection teams verify every connection using advanced imaging systems capable of detecting even the smallest defects. Thousands of embedded sensors continuously report structural behavior, allowing engineers to monitor the tunnel's performance in real time. With the first tunnel sections successfully connected, construction accelerates as the world's most ambitious floating underwater crossing gradually takes shape beneath Norway's spectacular fjords. Writing variant equals document ID equals 80,521. The floating pontoons act as the tunnel's primary support system, carrying enormous loads while remaining remarkably stable on the surface. 4. Precision hydraulic systems continuously adjust the pontoon's position, ensuring perfect alignment with the submerged tunnel below. 4. Massive articulated connections allow the tunnel to move naturally with waves while maintaining continuous structural support. Working deep below the surface, marine specialists complete one of the project's most technically demanding installation procedures. 4. Additional stabilization systems extend toward the seabed, where carefully engineered anchors help control movement during extreme weather. Each gravity anchor weighs thousands of tons, using its immense mass to provide dependable long-term stability beneath the fjord. Engineers gradually increase cable tension, balancing flexibility with strength until every support reaches its precisely calculated load. Real-time monitoring allows engineers to measure every movement, ensuring the floating structure performs exactly as predicted. Extensive simulations confirm that the floating tunnel can safely withstand powerful storms while maintaining structural stability and passenger comfort. With its floating support system securely in place, the project reaches a defining milestone, bringing Norway one step closer to transforming underwater transportation forever. With the main structure complete, attention shifts inside the tunnel, where thousands of individual systems must now be installed. Hundreds of kilometers of electrical and communication cables will eventually run through these overhead support systems. 5. Power distribution networks are installed throughout the tunnel, supplying electricity to every critical system operating underground. Powerful ventilation systems continuously circulate fresh air, maintaining safe driving conditions inside the enclosed tunnel. 15. Adaptive lighting technology helps drivers transition naturally between daylight and the tunnel environment, improving visibility and safety. 50. Emergency equipment is strategically positioned throughout the tunnel, ensuring rapid access should an unexpected incident ever occur. 50. Hundreds of intelligent sensors constantly monitor environmental conditions, allowing operators to detect problems within seconds. 50. Cross passages provide protected evacuation routes, allowing travelers to move safely between tunnel tubes during an emergency. 50. An intelligent traffic management system continuously monitors vehicle flow, automatically responding to changing road conditions. After years of engineering and construction, the tunnel's vital systems begin operating together for the first time, preparing for extensive testing before opening to traffic. Before welcoming its first drivers, every structural component must prove it can safely withstand years of demanding real-world conditions. 6. Thousands of embedded sensors instantly begin collecting data, providing engineers with a complete picture of the tunnel's structural performance. Specially loaded test vehicles recreate the heaviest traffic conditions the tunnel is expected to experience during normal operation. Even under extreme loading, the tunnel flexes only by carefully calculated amounts, exactly as engineers predicted during the design phase. Live measurements are continuously compared with advanced digital models, confirming that the real structure behaves exactly as intended. 6. Comprehensive emergency exercises verify that every evacuation route, communication system, and safety procedure functions exactly as planned. 6. The ventilation system rapidly adapts to changing conditions, maintaining safe air quality throughout the tunnel at all times. 6. Advanced monitoring technology continuously observes traffic conditions, allowing operators to respond immediately to unexpected situations. 6. Extensive trial operations evaluate traffic flow, vehicle behavior, and system performance before the tunnel can safely open to the public. After exhaustive testing and verification, the floating tunnel reaches a historic milestone. demonstrating that one of the world's most ambitious engineering concepts is ready for its next chapter. After years of planning, construction, and testing, the floating tunnel prepares to welcome its first official traffic beneath Norway's majestic fjords. Designed for continuous operation, the tunnel safely accommodates a wide variety of vehicles, while intelligent systems manage traffic around the clock. Advanced guidance systems continuously optimize visibility, traffic flow, and driver awareness throughout every section of the crossing. Positioned carefully within the fjord, the tunnel is designed to coexist with the surrounding marine environment while minimizing its surface footprint. Automated inspection systems regularly examine every section of the tunnel, identifying potential maintenance needs long before they become serious. Regular underwater inspections ensure that critical support structures continue performing reliably despite constant exposure to the marine environment. A sophisticated digital twin continuously compares live operating data with predictive models, helping engineers optimize long-term performance. 7. By providing a continuous road connection, the project has the potential to reduce travel interruptions and improve regional transportation efficiency. 7. If successful, this pioneering concept could inspire future underwater crossings in regions where conventional bridges and tunnels remain impractical. 8. Hidden beneath the surface yet destined to transform transportation, Norway's floating tunnel represents a bold vision of what engineering can achieve when innovation meets determination. Long after construction ends, advanced monitoring systems continue protecting the structure every second of every day. Unlike surface bridges, the submerged tunnel benefits from calmer conditions below the waves, reducing the direct impact of severe weather. Every support cable is engineered to absorb movement gradually, protecting the tunnel from sudden forces generated by waves and currents. During harsh Nordic winters, the floating tunnel could provide a dependable transportation link when weather disrupts traditional ferry services. In locations with exceptionally deep fjords, floating tunnels may offer an alternative where conventional bridges or seabed tunnels become increasingly difficult to construct. Improved transportation links have the potential to strengthen regional connectivity by reducing travel interruptions and increasing reliability. Environmental monitoring continues throughout the project's lifetime, helping researchers understand how the surrounding marine ecosystem responds over time. Engineers around the world are studying whether similar concepts could one day connect other challenging coastal regions with deep waterways. Rather than replacing existing infrastructure, the floating tunnel could become one part of a larger transportation system connecting Norway's remarkable coastline. From an ambitious engineering proposal to a symbol of innovation, the floating tunnel represents the pursuit of new solutions to some of nature's greatest challenges. Beyond a single crossing, the floating tunnel forms part of a broader vision to strengthen transportation along Norway's rugged western coastline. Future maintenance may rely increasingly on digital twins and artificial intelligence to predict structural changes before they become visible. Autonomous inspection technology allows engineers to monitor critical underwater components with remarkable precision while minimizing operational disruption. Designed to adapt continuously, the structure balances flexibility and strength as environmental conditions change throughout the seasons. Although storms may disrupt the surface, conditions deeper below the water often remain considerably more stable for the submerged structure. By improving connectivity between coastal communities, projects like this could reshape how people and goods move across Norway's dramatic landscape. The technologies explored here may influence future infrastructure projects, wherever deep water presents extraordinary engineering challenges. Hidden beneath the surface, the tunnel quietly performs its role while daily life continues almost unnoticed above. Few engineering projects attempt to work with nature on such an ambitious scale, while respecting one of the world's most extraordinary landscapes. From an ambitious concept to a groundbreaking engineering vision, Norway's floating tunnel demonstrates how innovation can redefine the future of infrastructure beneath the sea. Rather than standing alone, the floating tunnel forms part of a larger effort to modernize transportation along Norway's spectacular western coastline. Continuous monitoring provides valuable information that helps improve maintenance strategies and supports the design of future infrastructure projects. Advanced robotic inspections allow engineers to evaluate underwater components efficiently while minimizing disruption to daily operations. digital simulations continue evolving alongside real-world data, helping engineers understand how the structure performs throughout its operational lifetime. By moving transportation beneath the water, the tunnel reduces exposure to many of the environmental challenges faced by surface crossings. Reliable transportation networks can strengthen regional mobility, supporting commerce, emergency access, and everyday travel along Norway's coastline. The research behind Norway's project may help inform future infrastructure concepts, wherever deep water limits conventional engineering solutions. Engineering achievements become most meaningful when they blend into the landscape, while improving the lives of the people who depend on them. Almost invisible from above, the floating tunnel quietly demonstrates how engineering and nature can coexist beneath Norway's remarkable fjords. Projects like this challenge conventional thinking, reminding us that tomorrow's infrastructure may emerge from places once considered impossible to build. Hidden beneath the calm waters of Norway's fjords, the floating tunnel represents one of the most ambitious transportation concepts ever imagined. Designed for continuous operation, the tunnel could provide a dependable transportation link regardless of the changing conditions above. Whether or not this concept becomes widespread, the research behind it expands what engineers believe is possible beneath the world's waterways. Every generation leaves behind engineering achievements that redefine what future generations believe can be built. Some of history's greatest engineering breakthroughs are not the ones that dominate the skyline, but those that quietly transform the world beneath our feet. From towering mountains to the depths beneath the sea, Norway's floating tunnel challenges the limits of engineering imagination.